We've previously covered the kind of bonds that form between a metal and a non-metal and between two non-metal atoms. What about when a metal and a metal are bonded together? Well, they don't actually form any kind of chemical bond. If they're two different metals, they form something called an alloy. And if we're talking about a pure metal, such as iron or copper, the atoms in that are held together by a metallic bond. And to understand a metallic bond, it helps to understand the formation of ions again. We mentioned previously that metals form positive ions. If they're forming an ionic bond with a non-metal, great, they can give their electron to the non-metal, who will then form a negative ion, while the metal forms a positive ion. What if the only other atoms around are other metal atoms? Well, they all form positive ions. They form positive ions by kicking out their electrons, and those electrons have nowhere to go. So they actually form a discrete separate entity to the positive ions, metal ions. And we say that the electrons have become delocalized. That's a key word. What that means is they're not stuck to any one atom. For example, I've drawn here what a metallic structure would look like. It is many positive ions, metallic ions, in this layers, and these are the negative electrons. This electron can go here, 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 here. It can move all the way around, wherever it wants to go. It doesn't live around one particular atom anymore. And the word for that is delocalized. This is often described as a sea of electrons with little islands of positive ions in there. This is all stuck together by the electrostatic attraction between the positive ions and the delocalized background sea of electrons. So this positive sticks to this negative, making metals very strong, but also giving rise to some typical properties of metals. For example, they're excellent conductors of electricity. That in fact defines metals. Why? Because these electrons are free to move wherever they want to go. If you set up a potential difference, a voltage, they're going to move all one way or the other. Same goes for being malleable. They're malleable because the ions are not stuck to each other. They're stuck to the background sea of electrons. So if I give it a push, or if I try to bend it, the layers of ions will move around, but they'll still stay stuck to this free-flowing background delocalized sea of electrons. Meaning that metals are very malleable, they're very ductile, they're great conductors of heat and electricity, and it also gives rise to the properties of alloys, which changes their properties very slightly, but it means that an alloy is actually a mixture and not a compound. We'll cover alloys in more detail in a later video.